Welcome to the another session of software testing. Dear students, since last two lectures we have been studying about different case studies of software testing. We studied why software testing is essential, and by now we have convinced ourselves that software testing shouldn't be ignored, and scientifically we should test our software before it reaches to the hands of our customer, right? So now we will dive more into the software testing and we will learn some technicalities or some terminologies which are used in software testing. So the most oftenly used terminology is bug. You might have heard about a word or a sentence like this software is a buggy software, or application that I'm using is a buggy application. Buggy in the sense over here, the software doesn't work as you expect. Okay, so when we say something is not working as expected, we can call it as a bug. Okay, but this definition of bug is very vague. There are many other meanings which are attached to the bugs. And when we will dive more into the software testing, you will understand how this bug definition can be relevant in other aspects also. So attached to the bugs, there are other words which are used in software testing which are very predominant. So we will get used to these words soon. Now we will see the meanings of these words first. So the defect. Now what is a defect? Many times you have heard the product is defective. Most of the times we say this phone is defective, or this earphone is defective, or this device is defective. Why we say the defective? The defective means it has been deflected from its original function. If I say my mobile is defective, it exactly means my mobile is supposed to work like it should. So I am supposed to call through the mobile, so it should connect the call, it should receive the call. So this is nothing but the expected behavior from the mobile phone. But if it is deflected from the original behavior, and if I am not able to hear what other person is saying on the call, then I will say the phone is defective. So here the word defect means something which is not consistent with the expectations. What you expect is different and what the product is delivering you is different. So that is called as a defect. Then there are other words like a fault, problem. I will explain the fault, error, and then failure in another way. We will just go through the other terms now. The problem. Okay, generally we say something is not working means something is problematic. So this is also a oftenly used word in the software testing. Particular thing is a problematic, means it is not working as expected. Then there is an anomaly or variance. Variance in the sense it has been varied from the original expectations. So that is called as a variance. These are the words which are very close to each other in their meanings. Okay, so sometimes they can be used interchangeably also. But once we will get used to these words and when we will understand the details of the software testing, we will understand when to use which word. Okay, then there is an inconsistency. Inconsistency means something which is not consistent with the expectations. Okay, so what inconsistency exactly means? For example, suppose I am expecting some behavior from the product and it is delivering in a different way every time. So it is inconsistent. Okay, for example, I have a television. When I turn on the power on button of the remote, it turns on. Okay, so usually it should turn on. But there are certain times when I press the power on button of the remote, it doesn't turn on. That means it is inconsistent in its behavior. Sometimes it is turning on, but many a times it is not turning on. So that is inconsistent. Then there is a product anomaly. Product anomaly means in the sense product is not what exactly it should have. Okay, so for example, there is a calculator. Okay, now calculator should work addition, subtraction, multiplication and division. Okay, but addition feature is not working properly. So we can say there is an anomaly in the product. So it is not working what do we expect from us, from that particular product. and then there is a feature. This is a very beautiful word in the software testing. Many a times, suppose particular thing is not given in the specification, in the software specification. By now you know the SRS, isn't it? Software requirement specification. So suppose something is not specified in the software specification, and suppose that thing is added in the software. Okay, so generally it is called as a bug. Okay, it is called as a fault or bug. The reason, because that particular thing is not at all expected to be there in the software. Okay, so this is beautifully quoted as a feature. Many times software tester will actually say that is a bug, but that will be countered by the software developer as a feature. Now we will talk about remaining three terms, that is fault, error and then failure. Now why I have taken these three terms separately? The reason is because these three terms are related to each other. They are closely related to each other and we will see the relation now. Now first we will see the fault. Now for that we will go through one example. Let's consider you have written a code in which there is a condition if and else. Okay, so if condition is true, there is a path A which will be executed, and if condition is false, there is a path B which will be executed. Now consider there is certain problem in the path B. So if the condition is false and if the path B will be taken, then that particular problem can be encountered. But if the condition is true and if path A will be taken for the execution, then that problem will never be executed. Now let's consider the condition is true. So path A will be taken for the execution and your code will be executed perfectly without any issue. But let's consider if condition is false. Then what will happen? That particular path will be taken for the execution, path B will be taken for the execution, and in the path B that particular fault will occur. Okay, so the fault was already there but it wasn't triggered yet. But when the condition became false, that path was chosen for the execution and now that fault has been appeared. Now fault was already there. Now that fault has been transformed into an error. Earlier that was only a fault because if the condition was true, it was never taken. But if the condition was false, then only that path B was taken where that fault was there. Okay, so earlier that fault was undetected. But the moment we took the path B, that fault actually triggered and that transformed into an error. So that is called as an error. Okay, when the fault is actually triggered, that is called as an error. And now if that error would be handled properly, then alright. But if that error hasn't been handled properly, if we fail to handle that error, then what will happen? Our system will crash. So it will then transform into an failure. So there was earlier a fault which was undetected because of condition was true, so it was never executed. But the moment condition became false, that another path B was taken for the execution and fault was detected. The moment fault was detected and it was executed, that became an error. The moment error was handled, alright, then that would have become a fault tolerant system. Means if we would have handled that error, then that is called a fault tolerant system. You might have heard about the exception handling, or you might have learnt about the exception handling, isn't it? So if that error would have been handled by your code, then that is alright. Your code will still go on and you have saved your code from getting into the failure. But if you fail to handle that error, if you haven't written the proper code and error wasn't handled properly, then it will get transformed into an failure. So this is how these three terms are related to each other. So fault, error and failure. Okay, I hope you would have understood all these terms. These terms are very correlated to each other. Sometimes you can use them as a synonym to each other, but as you go dive into the software testing subject specifically, once you grab all the technicalities of software testing, then afterwards you will start using these terms very distinctly. Okay, you will precisely use the terms whenever it was required. You will not interchange these terms. But as an end user or as another person from outside from the system, you will feel all these terms are very similar. In fact, their dictionary meanings are also similar to each other. Okay, but when we dive into the software testing, okay, in detail, you will understand these terms are very different to each other, and you should use them very precisely whenever only required. Now we will see from where the problems can be get introduced in our system. So which are the different sources of problems? So the first source and the biggest source of problem is requirement definition. Now in the software development life cycle, in the software engineering, you learnt what do you do in the software requirements. Okay, when you gather the requirements from the customer, what generally we do, we gather all the requirements, what exactly the requirements of customers are, what is the expectation of customer, what customer is expecting from the software. Okay, so that is called the requirement gathering. But when the requirements are being gathered and if they are not been noted properly, okay, if they are incomplete or if they are inconsistent, if they are contradicting to each other, then that is the biggest source of our problem. Okay, because of that, whatever will be followed on afterwards in the software development life cycle, entire thing will become useless or entire thing will become buggy, isn't it? So the requirement specification is really required and it should be done very precisely. Okay, so that is the biggest source of the problem. Okay, that is called the requirement definition. Let's get to the example. We will take an example of software in which we wanted to store the data of student. Okay, now let's consider what user is expecting from the software. User is expecting that this particular software should store the data of student. Along with that, it should store other details of the student, like in which class student is learning, what is the batch, okay, then percentage of their students, and all these details should be stored. Now basically I will need that software in order to make the attendance of the students. Okay, so when the student is present, I can mark as a present. When student is absent, I can mark it as an absent. Okay, but the person who has taken the requirement from me has done everything all in order to store the data of student except attendance. So will that software will be useful for me? Absolutely not, isn't it? That software will not be useful for me. The reason, because the major requirement from my side was I wanted to maintain the attendance online in that software, but just because of it was written incompletely, that has become useless for me. Sometimes there is an inconsistent requirements, means contradicting to each other requirements. Requirement A and B, if they are contradicting to each other, if they are not getting aligned with each other properly, then that is called as a inconsistent requirements. So that is another source of the problem. Now if the problem has been not detected in the requirement definition, then what will happen? It will get forwarded into design phase. Okay, so if we know the requirements are not written properly, if they itself contains errors, obviously that will get translated into the design phase also. So obviously, because design is done based upon the requirement specification, so if the requirement specifications are not done properly, design will be also faulty. But there are other cases in which requirements are written properly, but the person or the system architect who is designing the software will actually do something wrong in the designing phase. So in that case, designing phase is the cause of the problem, or that is the source of the problem. Okay, for example, consider you have gone to the architect, okay, civil architect, and you wanted to construct a bungalow. Okay, now in the bungalow you have mentioned all the requirements that you need, okay, like 1 BHK or 2 BHK, what amenities you want from that house, and all that you have specified. But in the design phase, suppose architect has written it wrong, means he has understood your requirements properly, those were written down properly on the paper, but while he was drawing that architecture plan, at a time he introduced some errors in that. For example, dimensions are wrong. You asked him that you wanted to have a bigger drawing room than the kitchen, but he did exactly opposite of that. So in that case, the design has caused the problem, because design itself is faulty. It is not correct, isn't it? So that is another source of problem. Let's consider you have written the requirements properly. Architect has drawn the drawing accordingly, so design is flawless, it is perfect, and now you have gone into the implementation phase. Now that is the third phase of implementation. Okay, in the implementation, if suppose design is not understood properly by the person who is doing the implementation, then obviously that will cause the problem. That will again cause the problem for your software, isn't it? So that is the implementation. In the case of software development, if the programming is faulty, means the person who has written the code hasn't written it properly, or if the code is malicious, then that can cause the problem. So that will be the source of the problem for your software. Okay, so that is the implementation phase where the problems can occur, or from where the problems got introduced in our system. Then another phase or another source of problems is the support system. Okay, if you have chosen the wrong programming language for the implementation, or suppose compilers or debuggers that you are using is the wrong one or the faulty one, then obviously that will cause the problem for your software, that will actually introduce errors or the bugs in your software. So all these are nothing but the sources of the problems. Another major source of problem is inadequate testing of software. Means if the sufficient time or budget wasn't given for the testing of software, then obviously software wasn't tested properly. So most of the errors which might have been rectified during the testing hasn't been got rectified. So this is the another source of problem, that inadequate testing of software. Okay, so throughout this course we are trying to put forward one point, that software should be tested properly. Sufficient time should be given for the testing. Most of the times what happens, the time frame given for the entire project is like development 80% or 90% time would be given for the development, and only 20 to 10% time will be given only for the testing. But obviously that is not correct. Okay, the testing should be given equal importance as good as your development work. Okay, the reason, because testing a software is a different thing. We are looking at that software through a different angle. Developers were looking at it very different angle, and now as a tester you are looking at it in a different angle. So obviously there might be many things that you can uncover while you are doing the testing. So this is another source of the problem. Now most of the testing efforts goes on preparing the test plan. Okay, you have to prepare the test plan, you have to prepare the test cases for the testing, and while you are preparing the test cases, the major source of your input will be the specification, because you are designing your test cases based upon the specification. Okay, by now you know what is the specification. Okay, software requirement specification. The basic difference between the requirement gathering and SRS or the software requirement specification is that when you are gathering the requirement, oftenly the requirements are vague. They are not clear cut. Sometimes there are ambiguous requirements. So when you got the requirements in your hand, you have to figure it out which are the feasible requirements which can be implemented, which are non-feasible requirements. So suppose the requirement is feasible, then only you will take it for the consideration for the implementation purpose. Otherwise, there are many requirements which are simply non-feasible. For example, if the customer is asking that he wanted to have a speech recognition software through which he will speak and then the things will be getting written down. But as you know, for the speech recognition, the most of the neural network or the artificial intelligence goes in. Okay, so in a technical point of view, in technical standpoint, many times that is not feasible, or sometimes you have a very tight constraints. Okay, tight time constraints or the budget constraints. So in that case also, even though things looks feasible for you, they cannot be got implemented directly, because for that you have to do some sort of R&D, or most of the times you have to give more efforts for the development purpose. So when we transit from the requirement gathering to the SRS phase, or the software requirement specification or specification phase, we have to filter out the requirements, and the requirements which are really needed, okay, which can be implemented practically, will be taken into the specification. Now when the specification is written, there are two different ways, or there are two different categories in which specification can be written. One is called as a functional requirement specification, and another one is called as a non-functional requirement specification. Now what do you mean by functional requirements over here? Functional in the sense the requirements which are tangible. I can say I want to store a record of 1000 students. Now that is tangible. I want to say I wanted to mark a student of 60 students at a time. This is very tangible. So that is called a functional requirement, which we can actually write it down, and accordingly we can work. I can measure those requirements, isn't it? When I say I wanted to store a record of 60 students, 60 is a figure through which I have measured it. When I said I wanted to store a record of 1000 students, I have measured it. So that's why this is called as a functional requirements. There are some other examples like save, print, check the spelling, or change the font. These are some sort of functional requirements. Means here I can clearly specify what exactly I wanted to have from the software. So that is why it is called as a functional requirement. And there is another category that is called as a non-functional requirements. Now non-functional requirement in the sense, here I cannot measure it. Suppose I will say I wanted to have a software which is responsive. Now how do I measure the responsiveness? Or example, I will say I wanted to have a software which is easy to use. Could I say how it is easy? Can I measure it? For example, one software which is easy for me to use probably can be hard for the another user, isn't it? So here we cannot actually measure it. We cannot actually put the figures over here. So that is why we call it as a non-functional requirements. So there are requirements like a security requirement, reliability requirement, user friendliness, platforms. These all requirements are called as a non-functional requirements. Now as you have understood what is specification, now based upon this specification we have to lay down certain rules, so that as a software tester we can distinguish the particular thing that we have figured it out is a fault or whether it is not a fault. Because as a software tester we are not relying directly on the requirement, we are relying on the specification. And once we have the specification, based upon the specification as a base document, we can design all our test cases. And if we found something which is deviating from the specification, then we can call it as a bug. But there are certain other clauses which are also we have to consider while specifying particular thing as a bug or particular thing as a feature. So that we are going to see in the upcoming session. For today's session we have done with this only. If you have any doubts, we will sort it out immediately after this. Okay, so study properly and we'll meet again in the another lecture. Thank you.